For example 3 and 4, we're going to look at what changing the sign of y and changing the sign of x will do to the function. And just to make it a little more interesting, I'm going to use something different than the parent function this time. Let's do x squared plus 2 squared and look at what that would do to the graph of our function if we multiplied it by a negative 1. So we would have a negative x plus 2 squared. Okay, so we can go ahead and fill in my table. You can use the table from the previous problem because we used x plus 2 squared. So a negative 2 plus 2 is 0, 0 times 0 is 0, so we have 0. A negative 1 plus 2 is 1, 1 squared is 1. 0 plus 2 is 2, 2 squared is 4. 9, and then 16. Okay? And if I just multiply those y values times a negative 1, I would get 0, negative 1, negative 4, negative 9, and negative 16. Okay, so let's graph this. So at negative 2 I have 0, negative 1 I have 1, I have 4, 1 I have 9, so it's going to be off the graph here. Okay, so I have something that looks like that for the blue function. And then I can do the same thing. At negative 1, I have a negative 1. At 0, I have a negative 4. And this is going to be off the charts, but something like that. Something like that. Well, notice what happened. I have the same shape. It shifted over the same amount, and I know that already, that just simply adding 2 is going to shift it over to the left 2. But something else happened. It reflected across the x-axis. So even though I'm adding 2, that's just does one thing, which shift it to the left 2. But multiplying the function times a negative 1 is going to reflect it across the x-axis. It's going to do that every single time. So now let's look at how multiplying x times a negative 1 will shift the function, or transform the function. Well, let's do a different y1 again. Let's do x minus 1 squared this time. So a negative 2 minus 1 would be a negative 3, would give me 9. Negative 1 minus 1 would be a negative 2 squared would be 4. 0 would be 1, 0, and 1. Okay, and we already know it's going to simply shift our parent function to the right 1. So I have 1 at 1, 0, point there, point there. So our function y1 will look like that. And what would happen if I simply changed x to a negative x? Keeping the minus 1 there, but just simply changing it to a negative x. Well, negative 2 times a negative 1 is 2, minus 1 is 1, 1 squared is 1. So I have at negative 2 I have 1. A negative 1, oh, sorry, I skipped over the point. So this would actually be the 1. So a negative 1 times 1, oh, no. Sorry guys, I'm losing concentration. Okay, so that was right. A negative 2 times a negative 1 is 2, minus 1 is 1, 1 squared is 1. Okay, so now looking at a negative 1 times a negative 1 is 1, minus 1 is 0, 0 squared is 0, 0 minus 1 is a negative 1, negative 1 squared is 1, then you have a negative 2 squared would be 4, and a negative 2 minus 1 is a negative 3 squared would be 9. Okay, so let's graph and see what that one's going to look like. At a negative 2 I'm going to have 1. At a negative 1 I'm going to have 0. At 0 we're going to have 1. I can't graph anything today. Okay, so negative 2 we have 1. Negative 1 we had 0. 0 we had 1. 1 we have 4. And 2 we have 9. So it's going to look like that. Okay, well, what happened? Well, if we just look at this part, and if we look at this part, notice that both are 1 away from the y-axis. This one's 1 way that way, this one's 1 way that way. And they have the same shape. We could do the same thing with these interior parts. If I folded this, and you could try this, this little blue part would be directly on top of this little purple part if I folded it across the y-axis. So even though they're both shifted to the left and right of the y-axis, if you folded your y-axis, both functions would be directly on top of each other. So what does multiplying x times a negative 1 do to our function? It reflects it the function across the y-axis. So we have a mirror image reflected across the y-axis.